All right, if it's okay with you guys, I would like to progress to now a bigger problem called. I would like to progress to a bigger problem known as problem number 4. And maybe we might not be able to finish it now. It's going to be. I made a mistake. I should have done that one first. Guys, any questions so far? All right, let's just pause for a second, and I just want to let you know what I'll do is I'll be opening up some signups where you can do your presentation or demo, online demo session of your project, right? And I'll make time available from. I'll make time available for the purpose of your project. I'll make time available from Monday, right? From Wednesday. From Wednesday afternoon. No, Wednesday we have our lecture. From Thursday morning. From Thursday morning, even though I said the project is due on Friday, I'll make time available so you can sign up into any of those sessions and just come in. So it'll be like Thursday morning, 9 till 10, 10 till 11. So I'll allow 5 or 6 students to go into the 9 till 10 session. Then 6 students, 10 till 11. 6 students, 11 till 12. Then we have a 1 hour break. Then 1 till 2, then 3 till 4, then 5 till 6, right? Then Friday morning, starting at again, 9 till 10, 11 till 12, 12 till 1, 1 till 2, 2 till 3, 3 till 4, 4 till 5, all right? Then there might be some students with genuine reasons, they're sick, they can do theirs on Monday. This is the project demo, okay? I'm talking about the demo. I'll put an announcement up shortly. All right, the next question, guys, is, okay, what I want you to do is, I want you guys to go on the internet, and if you find some nice videos on sequence detectors, even I myself was looking at this video by this lady on sequence detectors, but she uses, it's good ones, some short videos. I know students don't like long videos. It's always good to watch short video, sequence detector or pattern detector. Try and cover all the different patterns available, 1011, 1101. Have a look at this one, really non-overlapping type, all right? So some of them, they would speak in English, which is good for you, all right? Go through as many videos as possible. And what I'm asking you is if you can post, if you come here, if you look at week 13, if you can post in the week 13 discussion, right? If you can post in the week 13 discussion, there is absolutely no, from now on, I think if you look at it, guys, your last lecture note upload was in week 12. Week 13, week 14, there is no lecture note uploads required, all right? There is no lecture note uploads required in week 13 and week 14. But in week 13, in the discussion, if you could in the week 13 open discussion, if you could place links of some nice videos which were helpful on the topic of sequence detectors and pattern detectors, all right? Okay, there's a lot of videos. In fact, I was trying to do this sort of setup. If somebody could help me out, that will save a lot of time rather than me typing up some of these lectures on Microsoft Word. That's what I was trying to do, but I couldn't do it with my phone. I don't know what sort of camera we would need. Okay, all right, guys, let's continue. Okay, come here. Let's see. All right, let's look at the question. Design a sequence detector which gives output 1 when any of the sequences shown below are detected. Okay, the circuit resets. The circuit resets after getting a sequence. So this is this design a sequence detector. Use a more machine model, right? Okay, circuit resets after getting a sequence using more machine model. All right, guys. The sequences are 1101, comma 1001, comma 1010. All right, this is a nice problem, guys. This is a nice problem which I have for you. The catch over here is that there are three sequences. There are three sequences: 1101, 1101, 1001, and 1010. Okay. Okay. Now, okay. So the catch. Let's look at let's tap up some notes. Some notes. Some notes. We have it's supposed to be more machine. Right? It's supposed to be a more machine. Or let's just do milli first, and then we can do. Let's just do it as milli first. Let's do it as a milli machine first. If you look at more machine, there's nothing different, not too hard about it. Only thing is you have to allocate one state in the end, all right? Okay, milli machine. It's a milli machine. And the sequences are those three sequences. All right. Okay, let's look at the table. Right. Okay. Let me blank all that out. Second. Okay. I'm just placing this over here. Okay. Hey, and just to let you know, let's do the working table, and then I'll try and draw your particular thing again. All right? Okay. Let's start off, guys. Let's start off. How do I do this? How do I do this without drawing? In Microsoft Word, is there a place where I can draw freehand, guys? Okay, don't worry. I'll figure it out. Okay, we'll do paint. This time it's not cyclic anymore. You see, over here, you had only nice, neat states, 5 states, 4 states, and all very neat, nice and dandy, like very neat, in neat shape. Now you'll see this is a real one. Okay, let's start off with the first bit, guys. There are 3 bits, right? Three sets. Now, if the first bit is 0, does it satisfy the first sequence? No, it doesn't satisfy the first sequence, right? Let's look at the second bit. If the second bit is, if the first bit, let's look at the second sequence. If the first bit is a 0, does it satisfy the second bit, second sequence? No, it doesn't satisfy the second sequence. If it is 0, does it satisfy the third sequence? No, in all 3 cases, it does not satisfy the 3 sequences. And if it is 1, yes, it does. So our bit string here becomes 0, and that becomes 1. And well, we go from A, we go to B. In both, from A we stay at A, right? And our output is 0, because we don't have a 0, we don't have a 1 until either of these 3 are satisfied. Now our receiving input over here is now 1. Our receiving input is 1. If we achieve a 0, guys, okay, this is where the catch is. If we achieve a 0, does it satisfy any of these 3 sequences? Yes, it does. Can you see it satisfies the third sequence? Satisfies the third sequence, right? And if it's a 1, does it satisfy any of these sequences? Yes. Okay, so if it was a 0, it satisfies the second sequence and the third sequence. So you get a stream of 1, 0. And if it's a 1, it satisfies the first sequence, right? So there we go. So we have a 1 and a 1. Well, this is where it's going to be hard for me. How do I draw this thing here? All right, okay. See, I'll need to paint over here. Put this at half screen. And I put this at half screen. Guys, can you see this table? I hope the table is clear. Guys, hello? Are you able to see the table and my paint? Both the screens?
Not the table clearly.
Okay, let me zoom into the table slightly more. All right, okay. All right, set. So we can now see both. All right. Okay, there we are. All right, so let me select pen. All right, hopefully this works this time. Better choices. What's the bloody thing? There's the shapes in here. Right, shapes. Nice, I like shapes. Right, so let me make this very small. And then I put a little A over here. A, okay. Okay, and then okay, right. So, and then I put another shape. Hopefully it works with, far out, what happened to my shape? Okay, okay, we have B, nice. Okay. All right. Okay. Let me make my arrow red. Is there a way to do arrows over here? No, no arrow. Okay. Primary arrow. Okay, that's my arrow from A to B. All right. Now, remember, we and that arrow and another arrow. Nice. I like this. All right. So if this was 0, if input was 0, if input was 0, it will stay at A, right? And output will also be 0. Okay. Okay. All right. Okay. And if input was a 1, output will still be 0. We can't achieve 0 until we have one of those three. Okay. Output will still be 0. Now, from B, we have two forks. There's two progressions. There's two ticks. So it's progressing in two directions now. So we can either go the direction of C. You look on the right hand side, guys. Sorry, I'm using my finger now. Look on the right hand side. Either we can go in the direction of C, or we can go direction of D. But both are progressions. Both are progressions. All right. So let's see. Hey. Sorry. There's something happening here. Oh man. Please hold. Please hold. Something is wrong. Sorry. Crashed. Okay. Back up again now. All right, let's move quicker. Let me type C. Let me type D. Okay. All right. So there's two progressions now, guys. There are two possible directions. All right. One is in that direction. All right. And the other is in this direction. So this is the catch. That's why I wanted to do this problem with you guys. So there are two directions. All right. Let me just save this before I lose this problem form. Don't worry. I'll share all of these documents with you guys. Okay. Okay. Now, if it was C, from going from B to C, let's look at our table. Going from B to C, you need a 0. So we have C and 0, D and a 0. Okay. Now, if you have an input of 1, right? If you have an input of 1, your current bit stream becomes 1, 1. Then you move to D, right? And if you have an input of 0, I'm doing this on my Word document now, all right? Your particular bit stream becomes 1, 0, and your input is C. Your next state is C. So let's put the thing there. So you have 0, then you go to C. And over here, you have 1. You still have an output of 0. You go to D. All right. Okay. Okay, next one, guys. Next one. Now, we now have to consider if our pass input is 1, 1. Okay. Sorry, if our past input is 1, 0, right? Okay, so we have to consider our past input as 1, 0, right? And the other possibility, so 1, 0 from here, we're picking it up from here, and there's another stream open now, 1, 1, right? Now, if your past input is 1, 0, and your current input is a 0, anything over here which satisfies, yes, you can achieve for the second sequence. So you get a 1, 0, 0. So you'll get a 1, 0, 0. And over here you get 1, 0, 1. All right. 1, 0, 1. Yes. 1, 0, 1. If you received a 1, your 1, 0, 1 is in your third sequence. So that's in your third sequence. All right. Now, so what state do we take it to? So that will go from C, it will go further. Zoom in. All right. Okay. Now from C, let me just crop this and move it to the side slightly. Okay. All right. Okay. So what do we assign it over here? Well, we have taken D. D is in the future. So let's just might as well do. If your pass was a 1, 1, and you get a 0, that will satisfy the first sequence. Right? If your pass was a 1, 1, and you get a 0, that satisfies your first sequence. And if your pass was a 1, 1, and your current input is a 1, right? If your current input is a 1, then, well, then unfortunately that does not satisfy any sequence. So you have 1, 1, 0. And over here you have a 1, 1, 1. All right. So let's now try and draw these two up. Now, so this will go from C to E. That will go to F, right? And this tick here will go to G. Every time there is a tick and you progress, you go forward, right? Remember that. Every time there is a tick, you progress to the next tick. But obviously, none of them have satisfied any of the 4-bit sequence. They're still in the 3rd bit stage, right? Right? And obviously, this one will obviously have a 0. But where will this one go? 111. Is there anything that has got a 111? No. Let's forget about the first bit. Let's just look at the past 2 bits. Anything with a 11? Yes. That's a 11. So we end up with D. Okay. Now, taking this information, which is over here, taking this information, let's now draw this thing here. From C, you go to E. So let's got two circles. Two states from C to E. All right, C, where did we go from C? C to E and C to F. So that's E, radio, and we have F from C to E and C to F. Guys, you can see my paint clearly? Can you see paint? Okay. All right, from C to E. All right. And from C to F, right? And from C to E, what is the sequence? We have to have a 0 input. In order to go from C to E, from C to E, our input has to be a 0. Right? Our input has to be a 0. And going from C to F, our input has got to be a 1. Guys, I think I've forgotten something over here. All right, let's go ahead and do that later on. But there's some cleaning up which we have to do. There's some things which we've forgotten. Now let's look at D. From D, we go to G. From D, we go to G, right? From D, we go to G. And that is only possible to go from D to G if your input is 0. Where did I pick that up from? Well, from D to go to G, we can only progress if our input is 0. And okay, guys, I've forgotten certain things now. Please remind me along the way, all right? What do we have here? What about if, let's look at B. With every state, there should be 2 ways forward. 0, 1 with B, right? With C. With C, 0, 1. With D, 0. What about 1? If D has a 1, where do you go? If D has a 1, we go to back to D. All right. So that's where this comes in. And that's what I like about this guy here. Okay. And to go from, sorry guys, that's in the wrong place again. My apologies. And from D. From D, if you get a 0, if you get a 1, you stay in the same place. All right. From D, if you get a 1, you stay in the same place. All right. Okay, we still haven't done yet. We still haven't done yet. Let's now move to the next. I'm now back on my Word document, guys. I'm back onto the Word document. Now our receiving inputs. Let me just expand this guy here. Okay, we have an F, and we already been told about our G. Okay, we have an EFG. So we've got to have in the table for those three guys there as well, right? Okay. EFG. Okay, now we're almost at 3 o'clock. I'm going to try and make this faster. So with E, what would have been the case with E? How did we arrive at E? We arrived at E from C with 1, 0, 0. So 1, 0, 0. That was the sequence which was arrived at E. What about F? How did we get to F, guys? We go to F with a 1, 0, 1. 1, 0, 1. 1, 0, 1. How did we get to G? We got to G with a 1, 1, 0. 1, 1, 0. 1, 1, 0. Guys, if you look at it on the table, you can just clearly see, you know, how did we get to E? So you just look at this 1, 0, 0, right? How did we get to F? It's 1, 0, 1, right? How did we get to G? 1, 1, 0, all right? Okay, now let's look at the next part. Now, if you have a 1, 0, 0, and then you have another additional 0, you'll end up with 1, 0, 0, 0. And if you have a 1, you'll end up with 1, 1, 0, 1. So 1, 1, 0, 1 is the right direction, right? We have finally achieved it. With 1, 1, 0, 1, we have got one of the sequences in the bag, right? Let's look at this one. And what about if it was a 1, 0, 0? Well, there's nothing as a 1, 0, 0 there. So that is out of the question, right? That is out of the question. Okay, now let's look at this one. 1, 0, 1, 0. 1, 0, 1, 0. Yes, so our third sequence is a 1, 0, 1, 0. Our third sequence is a 1, 0, 1, 0, right? Sorry. Our third sequence is a 1, 0, 1, 0. And what if it was a 1, 0, 1, 1? Is there a 1, 0, 1, 1? No, there is no 1, 0, 1, 1. There is no 1, 0, 1, 1. Right? Now let's look at this G. 1, 1, 0. From 1, 1, 0, is there any 1, 1, 0, 0? 1, 1, 0, 0. Is there any? No. There is no 1, 1, 0, 0. Is there a 1? Is there a 1? 1, 1, 0, 1? Yes, there is. The first sequence is a 1, 1, 0, 1. Right? So we have a 1, 1, 0, 1. 1, 1, 0, 1. All right. So let's now look at the progressions. We look at where the ticks are. So if you look at the progressions, 1, 1, 0, 1, where will that go to? 1, 1, 0, 1. And remember what the question said. The question said the circuit resets after getting a sequence. After getting a sequence, the circuit resets. Okay. So if the circuit resets after getting a sequence, so from E with this line here, reset means it'll go back to A, but with a 1. But with a 1. So what do we do? So from E, it will go from E, it'll go from E, it will go to A after receiving a 1. 1, slash 1 1 slash 1. Okay, now let's have a look at the next one. What about if E receives a 0? If E received a 0, that will end up at 1000. Well, again, there's nothing it can be done. It resets. So it goes to A again. It goes to A again, right? Because there's nothing with 1000. So it goes to A again, but with an output of 0. So we have 0 slash 0. Okay, let's look at F now. Let's look at F. Okay, let's look at F. F, where is it traveling to? From F, if it's a 0, it is progressing. Well, if it is a 0, it will progress to A, but with a 1, right? Okay, so another big one over here. F. Sorry, if F gets a 0, it will go to A. Okay, if F gets a 0, it will go to A with a 1. Or if it's got a 1, it's got a 1101, 1011. We'll have to figure out where that goes. So let's now place this thing here. Maybe I'll do something. Okay, and we have a if it's got a where does F progress? If it's got a 0, it will receive a, it will have a 1, and it will reset, because that's what the question said to us. Okay, now what about if F receives a 0? If F receives a 0, if F receives a if F receives a 1, that will become 1011. 1011. Now let's look at this thing here. 1011. Is it over here? No, none of the past inputs. So let's drop the first bit and let's look at the last 3 bits. 011. Are any of that possible? No. Is there any past receiving inputs with 011 combination? No. Let's drop the first 2 bits. Let's look at the last 2 bits now. 11. 11. Are any of the past or receiving inputs having that combination of just 11? Yes, D. D has got it. So we go to D, and of course it's a 0. So from F, we go to D, right? From F we go to D, and we have, what is the input? I always get confused. So that's 1, yeah, and 0. 1 slash 0. All right. Okay. 1100. 1100 will be, let's look at G. If it gets a 0, let's look at where it progresses. If it gets a 1, obviously it will reset. It'll go to A and it'll have a 1 if it gets a 1. So let's do the G one. I'll clean that up. Okay, and we have what's over here, guys? We can type a 1 and it will have an output of 1. All right. Okay, now let's have a look at this last window over here. What if it is a 110, and if it is a 110 in our past input, our current possible bit is a 0, therefore possible bit string becomes a 1100. Now 1100 is not a combination over here, so obviously the output is not 1. Now let's look at 1100. Is it appearing in our past receiving input? No. Let's look at just the 100. Just the 100. Does that appear in our receiving input? Yes, it's appearing at E. So we have E and 0. Yes, Kritesh. Yeah, it's E. Right? So where were we now? I'm getting confused myself. We were doing, which one were we doing? We were doing G. And G with 0, it goes to E. Holy shit. Look at this. It's going to be a big spider web now. And we have 0, 0. Okay, guys, I hope this is helpful. Let me copy this.
Sir,
Put it
we
in
don't
our
need to.
Sorry, guys.
We
Which
don't
one
need
did we miss?
an extra state to output 1 for this time because it says to reset.
Yeah. Sorry, that's true. We don't need to get the output state because in the end. One second, guys. Okay, we don't need to have a next state because the question I changed it right in the end. I said we'll use a milli machine. Okay, we use a milli machine. If it's a more machine, then what will happen? If I had asked for a more machine, then you would have another state called A B C D E F G maybe H, another state called H, and then you would connect that to H, and also your labels over here would change. You wouldn't have a 1/1. You'll just have a 1 or just a plain 0. Okay, all right, guys. Any questions? This is a big question. This is like an exam type question, but in your exam, I won't give double sequences. I mean, if I do, it'll be very short sequences anyway. So, hey guys, have a look at this. This is A, B, C, D, E, F, G. That's 1, 2, 3, 4, 5, 6, 7. 7 states. Therefore, you will need, how many flip-flops would you need, guys? How many flip-flops would you need? Anyone?
4.
7 states. Now, I think you can get away with three flip-flops. 7 states, you can get away with 3 flip-flops. Yeah, 3 flip-flops because the maximum number is 7. All right? Okay? The maximum possible combination with 3 bits is number 7. All right. So this is it, guys. This is another problem which we've done. We've done some good problems, and what I'll do is I'm not going to take it out for too long now. I'll upload the YouTube file straight away, and